Hello, good day. I am Angieliquie Mejilla from BSN-1A. Today, I am going to talk about carbohydrates. I'm going to discuss the occurrence and functions of carbohydrates, classifications of carbohydrates, chirality, stereoisomerism, the enantiomers, and diastereomers. So first, I'm going to talk about the occurrence and functions of carbohydrates. What is carbohydrates? So, carbohydrates are the most abundant class of bioorganic molecule found on Earth, but abundance in human body is relatively low. Also, carbohydrates constitute 75% by mass in dry plant materials. Plants produce carbohydrates via photosynthesis. So, photosynthesis is the process by which the plant make their own food using sunlight, water, carbon dioxide, and chlorophyll. So what is chlorophyll? Chlorophyll is the one who makes the plant colored. Plants have two main uses of carbohydrates they produce. First is in a form of cellulose, second is in a form of starch. In a form of cellulose, they serve as a structural elements, and it is made from alpha glucose. In a form of starch, it provides energy reserves for the plants, and it is made up of beta glucose. So cellulose is straight, linear, unbranched, and cannot be coiled or compressed. While starch is the opposite of cellulose. It can be coiled, and you can fit a lot of energy in a small space. It is the common way to store energy. Move on to the functions of carbohydrates in humans. First, carbohydrate oxidation provides energy. The second one is storage in a form of glycogen. We humans need carbohydrates for our cells to function. Carbohydrates serves as a fuel for our cells so that we can have energy. So, if we intake carbohydrates like rice, it is converted into a glucose because our body only needs glucose to form an ATP or energy for us to function. So if we intake, for example, if we intake carbohydrates, it is converted into glucose, and the excess of the glucose that we intake will be stored in our liver and muscles for future uses. Because, for example, today I eat a lot of carbohydrates and it is converted into a glucose. My body only needs 80% of a glucose. So the excess 20% will be stored on my liver or my muscles. And for example, the other day, tomorrow, I will not eat anything. So I don't have any carbohydrates to form an ATP for me to function. So my liver, my energy will come from my liver, which has the glucose that I stored last day. So that's the end of my discussion about occurrence and functions of carbohydrates. So, hi again. Let's move on to classifications of carbohydrates. So carbohydrates are biomolecules composed of one carbon, two hydrogen, and one oxygen atom. So there are two major types of carbohydrates, the simple sugar and the complex carbohydrates or complex sugar. Simple sugar consists of one or two sugar molecules, which is the monosaccharide and disaccharides. Complex carbohydrates are composed of three or more sugar molecules, like oligosaccharides and polysaccharides. So, sugar actually came from a sugar family called saccharides. So, we have four types of sugars: the monosaccharides and disaccharides under simple sugar, and oligosaccharides and polysaccharides under a complex carbohydrates. So, let's talk about simple sugar first. So, first is a monosaccharide. Mono means one and saccharide is sugar. So, these are composed of one sugar molecules. The first one is glucose. Glucose is the most important family of sugar. Glucose are also found in calories. Also, glucose can cross blood-brain barrier and it nourishes our brain. The second one under monosaccharide is fructose. Fructose is commonly found in honey, fruits, and vegetables. The third one under monosaccharide is the galactose. Galactose is a milk sugar. It is commonly found in nature when it is linked into a glucose to form lactose. So lactose is a type of disaccharide. So lactose is found in the milk of mammals like cow milk and breast milk in humans. When glucose is linked into a galactose, it will form a lactose. The second one under disaccharide is a sucrose. Sucrose is also found in fruits and vegetables. When glucose and fructose link together, it will form a sucrose. The third one under disaccharide is a maltose. When two glucose link together, it will form a maltose. So, maltose is used in fermenting a beer. So, let's move on to complex carbohydrates. Complex carbohydrates is composed of oligosaccharide and polysaccharide. Oligo means few and sugar means is saccharide. So few saccharide. This contains 3 to 9 sugar molecules linked together. Oligosaccharides are found in soybeans. And polysaccharides, poly means many, so it's many sugar linked together. So polysaccharide is the most abundant type of carbohydrates found in food like rice, wheat, and potatoes. So that's the end of my discussion about the classifications of carbohydrates. So hi again. Let's talk about chirality. So what is mirror image? Mirror image is a reflection of an object into a mirror. Objects can be subdivided into two on the basis of their mirror image. One is object with non-superimposable and objects with superimposable mirror image. So, what is chirality? Chirality is a type of isomer. Two compounds, same formula, but different in arrangement. This is a form of chiral. So, as you can see, the formula is the same. These two compounds consist of 3 carbon atom, 8 hydrogen atom, and 1 oxygen atom. But the difference is that they differ in their arrangement of the oxygen atom. So, this is an example of chiral. One is N-propyl and the other one is isopropyl. So, chiral is our hands. Chiral is our hands. And it is non-superimposable. Why? Because our hands, whether you turn it upside down, it will be not superimposable. Even if I turn it upside down, it forms like this. It's not superimposable. So, it's chiral. So, a chiral is superimposable. Why? Because, for example, this letter A and this upside down letter A. If I turn this upside down letter A, so it's superimposable. So it's a chiral, meaning not chiral. So let's move on to stereoisomers. So stereoisomers are isomers that have the same molecular and structural formula but differ in the arrangement of atom in space. So stereoisomers can be subdivided into two types, the enantiomers and the diastereomers. Enantiomers are non-superimposable images like our hand, and diastereomers are superimposable images like this letter A. So that's the end of my discussion. Thank you for watching.